Okay, in this example, we're going to talk about the quadratic formula. So you've heard of it, I'm sure. X equals negative b plus or minus radical b squared minus 4ac all over 2a. And it looks kind of scary until you realize that the letters, the a, b, and c, they're just simply from your quadratic equation. The a is your coefficient of x squared, the b is your coefficient of x, and the c is your constant, your number without the variable. We're going to look at doing some of these problems today by hand. We're going to look at how it also looks graphically. So again, comparing your algebraic to your graphical solutions. Before we jump into doing some quadratic formula problems though, we've definitely got to work on reducing some radicals. So in case you forgot this, you may want to check out some other videos. If not, let's just jump into looking at some of these. Reducing radical 32. Well, it's a square root. 32 is not a perfect square. You got to find the highest perfect square that goes into 32, and that happens to be 16, 2 times, because 16 times 2 will give me a 32. We like 16 because 16 is a perfect square. It's actually 4 squared. So we write 4 squared times 2. And we go back to that same mathematical process. A square and a square root are opposites. They cancel each other out. So that 4 can come outside the radical as a 4, not a 4 square, because the square and the square root cancel. And the 2 doesn't cancel. It remains on the inside. So radical 32 is really 4 radical 2. Same thing. Let's do radical negative 50. That negative underneath your radical means you're going to have an imaginary answer. Going to have an I. Because you can't take the square of a negative number. Same process. We're going to have 3 numbers this time. That negative 1 and then 50. Okay, and then we're going to look at what goes into 50. So negative 1 times 25 times 2. There's my perfect square because 50 wasn't a perfect square. And then negative 1 times 25 is really 5 squared times 2. And again, look at what cancels. That square and square root, they're opposites, they're inverses, they cancel. That 5 comes outside the radical as just the 5, not the square, because it cancels. This negative 1, it's your imaginary number. So it can actually come outside the radical, but not as a negative 1. It comes out as that imaginary, that I, what you always see in your answers. This 2 doesn't cancel with anything. It stays inside your square root. So 5i radical 2 is the same thing as radical negative 50. Let's do one more. Radical negative 100. That's radical negative 1 times 100. And hopefully you recognize real quick here that 100 is a perfect square. So you got radical negative 1 times 10 squared. That 10 squared, that square and square root cancel, so 10 comes outside again, just a 10 because the square and square root cancel. That negative 1, that's your I on the outside. So they both came out, which means nothing's left on the inside. So your answer is just 10i. Not radical 10i, but just 10i. Okay? That's a little bit of review of reducing radicals because in your formula, you got the big radical you have to take care of. Let's do an example of your formula. Let's do 3x squared minus 4x minus 3 equals 12. We're going to get this equal to 0 first. So I'm going to subtract my 12 to get 3x squared minus 4x minus 15 equal to 0. And now, I like to do the graph first. I want to see what this does graphically. Then we'll come back and look how the algebra matches the graph. So I'm going to jump to my screen of my calculator. I've already got my quadratic typed in. 3x squared minus 4x minus 15. Now I need to play with my window because I know that my y-intercept is negative 15. So my y-min right here needs to be bigger than a negative 15, or I guess smaller than negative 15, but a larger number for most kids. So negative 20, let's say. My max is at 20, that's fine. I'm going to count by 4, that's fine. Let's look at the graph now. There's my quadratic. And here's what I want you to understand. This quadratic touches the x-axis 2 times. Because this quadratic touches the x-axis, we know we have 2 real answers, not imaginary. The question is real rational or real irrational. We don't know yet. We kind of have to walk through this and find out. So we're going to try to find out these solutions, these zeros, these x-intercepts. And we can do it graphically first by the same process we've been doing in all the other videos. Second trace. keyword up here is 0. That's the same thing as a root, an x-intercept, or a solution. So you want to go to 0. You want to come over here with your cursor to this big red dot, this intersection point. So come all the way over. Notice down here it says left bound. That means you want to get on the left side of my red dot, the intersection point. So left side, enter. Then it says right side. That means come to the right side of that red dot, hit enter. Then it says guess. To guess, just get as close to the dot as you can. Hit enter. And we have a solution right now, which is a negative 1.667 if I round. That's one of my answers. Let's look at the other answer. Second trace, keyword again, 0. Go to your other solution. You want the left side of this other solution, so now be careful. Left side on this case happens to be below, so I need to come back. It'll be below. Left side is below on this side. So hit enter. Go above, hit enter. Go on top, hit enter. And in this case, I get the answer, x is 3. So I've already got 2 answers graphically. Let's see how those graphical answers match up with my algebraic using my formula. So I'm going to go back to my original screen here. Let's use our formula. So let's go through here. X equals negative b. B is my negative 4. Plus or minus the radical b squared. So negative 4 squared minus 4 times a, that's my 3, times c, that's my negative 15, all over 2 times a, which is 3. And right now that looks very, very, very ugly, but we can simplify it real quick. Negative 4 is a positive 4. My 2 times 3, well, that's a 6. And notice I left off the inside of this radical. For those that have watched my previous videos, b squared minus 4ac, that's your discriminant. You can do that on the calculator real quick, or you can do it in your head and get a number here. But this discriminant is going to help me classify what my zeros are. So if I do this on the calculator, I'm going to end up getting 196 in here. Why is that important? Well, if my discriminant is 196, then I know already that's positive, that's a perfect square. I'm going to have 2 real, rational solutions. Zeros, x-intercepts, whatever you want to call it. Okay? So let's continue so we can go ahead and get those 2 rational answers. I'm going to reduce this radical real quick. 196, well, that's actually going to be 14 squared. And we know the square and the square root cancel, so it's really just going to be 14. How does that play? Well, that comes back over here. 4 plus or minus, instead of this radical, you just told me 14 over 6. Almost finished. You've got x equals this plus minus sign. That confuses some people. It just means 2 problems. One's a plus problem, one's a minus problem. So 4 plus 14 over 6 and 4 minus 14 over 6. Go through the math here. What's 4 plus 14? Well, that's 18 over 6. 4 minus 14, that's a negative 10 over 6. Let's do some reducing. 18 divided by 6, that's 3. Negative 10 over 6 reduces to a negative 5/3. Well, let's think graphically. Graphically, we got 3 for an answer. Algebraically, we got 3 for an answer. Graphically, we got a negative 1.667. Algebraically, we're getting a negative 5/3, but they are equivalent. They are the exact same thing. So again, we can see with the quadratic formula or the graph, if they're real answers, you get the exact same thing. Check out the next video for 2 more solutions.